Let us now look at a simple application of the RS latch. Let us look at this circuit. We have a power supply here, Vs, say 5 volts. We have a switch here. The switch position can be either like that or like that. And then we have a load, R. That is our output voltage across the load. Now when the switch is thrown from A to B, our output voltage is expected to go from 0 volts to Vs, say 5 volts. When the switch is in that position, position A, then PO is of course 0, and when the switch is thrown to that position, then we expect VO to be 5 volts, like that. Let us say that the switch position is changed from A to B at t equal to 0 right here. Then this is what we would expect as the waveform for VO. In reality, what we get is this waveform, for example. And instead of one single transition from 0 to 5, we have some other strange waveform, and finally it settles down at 5 volts. Now this happens because mechanical switches suffer from chatter or bouncing. That is, the transition from A to B is not a single clean transition. There are times when the switch is neither firmly in this position nor in that position, and that gives rise to these oscillations. As a result, VO oscillates between 0 volts and 5 volts before settling down to its final value over there. So clearly there is a problem. Instead of a single transition, we have now got this strange waveform, and in some applications this chatter can cause malfunction. For example, if we are counting these low to high transitions using an electronic circuit, we will feed that VO waveform to that electronic circuit, and the electronic circuit will then count these low to high transitions. So what we expect is that the count will go up by 1 when we turn the switch from A to B. In reality, what will happen is the count will go up by 3 because there is one transition here, another transition here, and a third transition here. So clearly there is a problem, and we need a way to remove this chatter. Let us now consider this circuit, which uses an RS latch. Here is the mechanical switch, which has this chatter or bouncing problem, which we want to remove. Consider two positions for the switch. Position A, in which this connection is open, input S is 0, and input R is pulled up to 5 volts because this part is open circuit. When the switch is in position B, then R gets connected to 0. This is an open circuit, and S gets pulled up to 5 volts. That means as we change the switch position from A to B, we go from S equal to 0, R equal to 1, this situation here, to R equal to 0, S equal to 1. So our intention is to go from this situation S equal to 0, R equal to 1, that is the switch in position A, to this position where S is 1 and R is 0, that is the switch is in position B. And for this condition, S equal to 0, R equal to 1, we have Q equal to 0, and for this condition, S equal to 1, R equal to 0, we have Q equal to 1. So the transition that we want is Q going from 0 to 1. And there is a problem because we have this mechanical switch, and that gives these oscillations in the S input as well as in the R input. Let us now check whether these oscillations in S or R inputs give us the same problem that we saw in the last slide, that is, multiple transitions in the output. Let us start at this point, S equal to 0 and R equal to 1. This first row here, Q is 0, like that. And now at this point, S goes from 0 to 1. R continues to be 1. So we now have S equal to 1 and R equal to 1. And that means that Q will continue with its previous value, which was 0. So Q continues to be 0. At this point, S changes from 1 to 0. And once again, we have S equal to 0, R equal to 1. This row here. And Q remains equal to 0. So that happens all the way up to this point. At this point, R changes from 1 to 0. S has already reached its final destination, that is S equal to 1. So in this interval, we have R equal to 0, S equal to 1, R equal to 0, S equal to 1. So Q will become 1. So Q will go from 0 to 1 here. And now in this interval, R has changed again to 1. So we have S equal to 1, R equal to 1. But Q will now hold its previous value, which is Q equal to 1. So therefore Q does not change. And finally we have S equal to 1, R equal to 0, S equal to 1, R equal to 0, and Q remains equal to 1, like that. So therefore we have now achieved a single clean transition in the output, although we do have a mechanical switch which gives us bouncing problems. And this process is called debouncing.